All right, so yesterday we started working on graphing inequalities in two variables, which is graphing our line, but we have some extra steps. The first thing we have to know, is it going to be a dashed or a solid line? And again, the solid line, the inequality symbols that go with that solid line are our less than or equal to, greater than or equal to. So if there's a line under the inequality sign, that means it's going to be included. Our dashed line here is just going to be our less than or our greater than. So those answers on that line are not included as part of our solution. And that help, and then we have to determine which side to shade. So then we pick some points. So we looked at some questions. We looked at a vertical line, how we would do if there's only an X. Then we started looking at some that are in slope-intercept form. They were already in slope-intercept form for us. And then we looked at one where there was just a Y and not an X, and that's a horizontal line. And then on problem G, we were working on this one. We just need to finish our shading here. First, if it's not in slope-intercept form, we have to solve it to put it in that where y is by itself, so that we have our slope and our y-intercept. So we solved it, and we got y is less than 4/3 x plus 4. We determined it's going to be a dashed line. The slope was 4/3. The y-intercept was 4. So we've already graphed that. Remembering that if you divide by a negative with an inequality, you do have to reverse the direction of the inequality symbol. So we were just getting ready to pick our points here. I like 0, 0 if it's not part of the line. So I'm going to pick 0, 0 for the right side. And again, because I have a denominator of 3, I'm going to go with -3, +2 as my second point. So those are the 2 points I'm testing, -3, 2, and 0, 0, to see which of those gives me a true statement, so I know which side of the line to shade. So remember, each of these is giving me an x, y that I'm going to substitute back into that inequality. So this one, 2 is less than 4/3 times -3/1 plus 4. So 2 is less than -12/3 plus 4. 2 is less than -4 plus 4. 2 is less than 0. And we know that to be false. 2 is not less than 0. So that means when I substitute in 0, 0, it should give me a true statement. So here 0 is less than 4/3 times 0 plus 4. 0 is less than 0 plus 4. 0 is less than 4. That is true, which means I need to shade the side of the graph where 0, 0 is. So all these points out here would make this inequality true. That is what the point of the shading is. Anything that falls in the shaded area is making that inequality true. All right, we've got some more problems on the next page. Problem H, x minus 2y is less than or equal to 0. Again, it is not in slope-intercept form, so I need to get it there. So I start by subtracting x from both sides. So -2y is less than or equal to -1x plus 0. Divide everything by -2. And again, because I'm dividing by a negative, that less than or equal to is going to get reversed and become y is greater than or equal to. -1 divided by -2 is +1/2 x. 0 divided by -2 is still 0. So we would really just write this as 0 is greater, excuse me, y is greater than or equal to 1/2 x. We wouldn't write the plus 0. Now we have greater than or equal to, which means that this is going to be a solid line. My slope here is 1/2. And because there's no plus or minus number here, my y-intercept is going to be 0. So when I go to graph that, I start at the origin at 0. The slope says to go up 1, 2 to the right, up 1, 2 to the right. And I'm going to use my straight edge to graph my solid line. So that's what my line should look like. Now, for the first time, I can't use my favorite point to test because my favorite point, the line goes right through it. So I have to pick points that aren't 0, 0 this time. And again, because of that denominator of 2, I want to use +2 and -2 in there just to make the math a little easier. So on the right-hand side, I'm going to go with 2, 0. And on the left-hand side, I'm going to go with -2, 0. So I can't use 0, 0 this time because it is one of the points on the line. So I have to test -2, 0 and +2, 0 to see which of those gives me a true statement. So 0 is greater than or equal to 1/2 times -2/1. 0 is greater than or equal to -2/2. 0 is greater than or equal to -1. That is true. 0 is greater than any negative number. So then I test 2, 0. 0 is greater than or equal to 1/2 times 2/1. 0 is greater than or equal to 2/2. 0 is greater than or equal to 1, and that is false. So I want to make sure that I am shading the side that gives me the true statement, which was the -2, 0. So I need to shade the top side of the line. So obviously it's several steps past just graphing the line that we have to take into account here to make sure that we get all of the steps in. Graphing a line is just a couple steps. Graphing an inequality, there are several more because of the solid versus dashed. Determining which side of the line we have to shade, and then actually shading that side of the line. All right, problem I, 2x plus y is less than -3. Again, this one is not in slope-intercept form, so I need to start by subtracting 2x from both sides. So we have y is less than -2x minus 3. I don't have to do any dividing this time. We've now got y by itself. So we're ready to start in on, is this a solid line, a dashed line? What are my slope and my y-intercept? Again, this is just a less than. So this is going to give me a dashed line. My slope here is -2, and my y-intercept is -3. So that's enough information for me to graph the line. I start with my y-intercept at -3. That's where my first point goes. My slope is -2, which tells me to go down to 1 to the right. Since I can't go down and to the right again, I can go back to that y-intercept and go up 2 and 1 to the left. Again, just to give me more points to line up. And now I need to make sure when I'm drawing this in that I'm drawing it in as a dashed line, that there's clear separation between my dashes. Because remember, a dashed line means any point on the line is not included in the solution. And then once my line is graphed, now I have to go to choosing those points. My favorite point 0, 0 is available this time. So for the right hand side here, I am going to pick 0, 0. Now for the left hand side, my slope is a whole number, so I really could pick any of those. I'm just going to go with -5, 0. Again, I like doing math with 0 because it's easy. So I have to test -5, 0 and 0, 0 to see which of those gives me a true statement. Now remember, if you do this and both of them give you a true statement or both of them give you a false statement, you need to go back and check your math, because one of them needs to give you a true statement, one of them needs to give you a false statement to make sure you have done your math correctly. So when I substitute in, again, remembering every ordered pair is an x and a y. So -5, 0 would be 0 is less than -2 times -5 minus 3. So 0 is less than +10 minus 3. 0 is less than 7. And that is a true statement. 0 is less than 7. So if I've done my math correctly, 0, 0 should give me a false statement. So 0 is less than -2 times 0 minus 3. 0 is less than 0 minus 3. 0 is less than -3, which we know is false. 0 is greater than any negative number, so this is false like we were expecting. So we need to shade the side that has the -5, 0 that gave us the true statement. So we're shading that side of our graph. All right, problem J, 4x minus 3y is greater than or equal to -6. Again, we are not in slope-intercept form, so our first step has to get it into slope-intercept form. So we're going to start by subtracting 4x from both sides. So we have -3y is greater than or equal to -4x minus 6. Then we need to go in and divide everything by -3. And again, because we divided by a negative, we have to reverse the direction of our inequality symbol. So it becomes y is less than or equal to -4 divided by -3 gives me +4/3 x. -6 divided by -3 gives me a +2. So once I'm in slope-intercept form, I have y is less than or equal to 4/3 x plus 2. So it's a less than or equal to, so that is going to be a solid line. My slope is positive 4/3, and my y-intercept is going to be at positive 2. And that's all the information I need to graph the line part of it. Again, once we graph the line, then we still have to do the testing of points on either side to see which side of that line we are going to shade. So I start at positive 2 on my y-axis. I have a slope of 4/3, so I go up 4, 3 to the right. Since I can't repeat that, I go back to my y-intercept and go down 4 and 3 to the left. Again, it just gives me another point to make sure that I have counted correctly because they should line up. And it's a solid line, so I draw in my line. And again, a solid line means that any point on the line is also a solution to the inequality. The line is included in the solution. So now that I have my line graphed, I need to pick my points. Again, on the right hand side here, 0, 0, my favorite point is available. And then I need a point on the left side. And again, I have a denominator of 3, so I want something in the -3. So I'm going to go this time with -3, 1. So those are the points I need to test, -3, 1, and 0, 0, to see which one gives me a true statement. So 1 is less than or equal to 4/3 times -3/1 plus 2. 1 is less than or equal to -12/3 plus 2. 1 is less than or equal to -4 plus 2. 1 is less than or equal to -2. And that is a false statement. 1 is not less than or equal to -2. So I'm expecting the 0, 0 to give me a true statement if I've done my math correctly. So 0 is less than or equal to 4/3 times 0 plus 2. 0 is less than or equal to 0 plus 2. 0 is less than or equal to 2, and that is a true statement. 0 is less than 2. So I need to shade the side that has 0, 0 on it, which means I'm shading this side of the graph. This is where all the points are that will make that inequality true. All right, the next page, we still got a couple more here. K, x is less than 2. Again, this is another one that only has one of the two variables here. So when it's an x, that means we are going to have a vertical line at 2. And it is just a less than, so this is going to be a dashed line, which means any point on the line will not be part of the solution because a dashed line is not included. So I go to 2 on my x-axis, and then I use my straight edge to draw a dashed vertical line. And again, then I need to pick points on either side of the line. On the left side here, my favorite 0, 0 is available. And then on the right, I'm just going to go with 4, 0. So the points I'm testing are 0, 0 and 4, 0. And here again, I'm only concerned about the x coordinate because that's all that's in my inequality. So if I substitute in here 0 is less than 2, that is true. 0 is less than 2, which means I expect the 0 to give me a false statement. 4 is less than 2, and that is false. So I am going to shade the side of the graph that has the 0, 0, which means I'm shading the left-hand side of the line, which again, the shading means any point in the shaded area is a solution to that inequality. Now we have one more problem. Problem L, 3x plus 5y is greater than or equal to 5. I am actually going to pause at this point, and I'm going to give you a chance to work that one through, and then we will check our answer. So I'm going to pause while you do that one, and I'll hand out the homework that goes with this set of notes as you're working on problem L. All right, so we have 3x plus 5y is greater than or equal to 5. So we have to start by subtracting that 3x from both sides, because again, we need to put this in slope-intercept form. So 5y is greater than or equal to negative 3x plus 5. Then we need to divide everything by 5. Now, this time we divided by a positive number, so we are not reversing the inequality symbol. This is staying y is greater than or equal to negative 3 over 5x plus 1. And again, because it's a greater than or equal to, this is going to be a solid line. My slope is negative 3/5. My y-intercept is 1. So I graph my line. I start at positive 1 on my y-axis. I go down 3, 5 to the right. Again, since I can't repeat that on the right, I go back to the y-intercept and go up 3, 5 to the left. Again, it just gives me another point to line up my graph. It's a solid line, so I'm drawing my line using my straight edge. And again, I need to test my points on either side. I can on the left side here. My favorite 0, 0 is available. And since my denominator is a 5, on the other side, I'm going to go with 5, 0. So I'm testing 0, 0 and 5, 0 to see which one is going to give me a true statement. So 0 is greater than or equal to negative 3/5 times 0 plus 1. 0 is greater than or equal to 0. Oops, that's supposed to be plus 1. Plus 1, so 0 is greater than or equal to 1. That is a false statement. 0 is not greater than or equal to 1. So I'm expecting 5, 0 to give me a true statement. So 0 is greater than or equal to negative 3 over 5 times 5 over 1 plus 1. 0 is greater than or equal to negative 15 over 5 plus 1. 0 is greater than or equal to negative 3 plus 1. 0 is greater than or equal to negative 2. And that is true. 0 is greater than any negative number because all of the negative numbers are left of 0 on the number line. So I need to shade that side of the line with 5, 0. So this is what your solution should have looked like when you finished shading. So again, you need to make sure your inequality is in slope-intercept form. You need to determine it as a solid line or a dashed line. Once you've graphed it from your slope and your y-intercept, then you have to pick your points on either side of the line to test to see which one gives you a true statement, so you know which side of the line to shade, and that's where all your solutions lie.